All of our key advances over history have often been tied back to materials, and the people who knew how to do things with materials were considered very special. You know, the blacksmiths back in the day were well regarded, and if you're a material scientist now, you might not be a blacksmith, you might be a metallurgist, but you're still doing the same sorts of things with more knowledge and more advanced equipment.
We're basically looking at the molecular structure of materials and how to control that to get the desired material properties that we want, so that those function the way that the engineer wants it to function, whether it's a cell phone or an airplane or a medical device.
Materials science is an amazing field where basically you discover how to make like a part or material better. You optimize it basically so that you get your desired performance.
So all of our labs are shared labs. That means that both undergraduate teaching and graduate level research go on in these labs. We have a lot of materials characterization equipment.
This is a selection of labs that cover a lot of the core material science knowledge fundamentals, things like material processing, material properties.
We work in our department with anything from biological materials, radiological materials, metals, ceramics, polymers, soft materials, composites, anything you can think of. Our researchers are working with it. We have thermal analysis, we have microscopy, we have metallography, we have other spectroscopy and some other molecular analysis that they can do too, mechanical testing.
Most of our undergrads that work in labs are either in a lab for a class, which means they're in the department, or they're in a lab working for somebody. And we have a lot of undergrads that are actually hired to work as research assistants.
So they have equipment that they will see in industry, and they will get to have hands-on experience with that equipment. Not a lot of departments do that. I would say the key piece of equipment that we let them use that a lot of departments don't is the scanning electron microscope, and they'll know how to use that when they go into industry.
The work that I've done is involving underwater adhesion. It involves preparing an elastomer like you saw and then using it within a material to optimize how you get adhesion when in a wet environment.
Key fundamental principle of anything is if you're going to make something, you got to make it out of something. And if you want it to be lighter, faster, better, stronger, tougher, be able to operate at a higher temp or a lower temp, you have to often design a material, or at least pick a material that's suitable for that design.